Hello everybody. Today we're going to start with the topic called as security mechanisms. Earlier we have discussed the types of attacks and security services. That was my first series of video. Today we're going to start with the second video of this entire course, which is security mechanisms. Now, what do you mean by security mechanisms? Basically, security mechanisms are the mechanisms that helps in achieving security. There are different types of mechanisms that helps in achieving security in different organizations. You can define security mechanisms as the mechanisms that are designed to detect, prevent, or recover from attacks. So basically, mechanisms helps you to detect, recover, and prevent from attacks. So these three are the functionalities of mechanism: detect, recover, and prevent. There are different types of mechanisms. Basically, security mechanisms can be divided into two parts: specific security mechanism, and the second one is pervasive security mechanism. Talking about specific security mechanism. Now, specific security mechanisms are those that are specific to particular OSI security services or protocol layers. Whereas talking about pervasive security mechanisms are those mechanisms that are not particular to OSI security services or protocol layers. If you remember, we had already studied about OSI layers. The networking, now when you talk about networking, there are different protocols, and those protocols have specific layers. Now, when we talk about specific security mechanisms are specific under those layers. Whereas pervasive security mechanisms are those mechanisms that are general for all the layers. They're not specific to any particular layer. Okay, moving ahead as to what is specific security mechanism. Specific security mechanisms, as I've already told you, is specific to particular layers in the OSI or any other protocol that the network is following. Specific security mechanisms can be further classified as different mechanisms. The first mechanism in specific security mechanism is encipherment. Now, what do you mean by encipherment? Encipherment is the use of mathematical algorithm. I hope you understand what is algorithm. You've already gone through the algos, different algos. Algorithm is the set of steps for executing a program. So encipherment is the use of mathematical algorithm to transform a plain data, into a form that nobody can understand. That is a simple message that can be read by anybody. If that simple message is sent as it is, that is not security mechanism. What I'm saying is, if a simple message is converted into a form that nobody can understand, is called as encipherment. So encipherment is the use of mathematical algorithm to transform data into a form that is not readily read or understood. That is called encipherment. And this is the first mechanism of security, which is very specific to the layers. Different layers can use different encipherment mechanisms. There's not one encipherment mechanisms. There are different encipherment mechanisms. Moving to the second specific security mechanism, which is digital signature. Now, what do you mean by digital signature? Digital signature is a proof that the that the person who's sending the message is the authorized person and is the one who's sending the message, who it claims to be. That is, actually, if I'm claiming to be A and if I attach my signature, I prove that I am A. This is called digital signature. Now, how do you do that? Now, digital signature can be done by appending data. You can append a data that is very, very unique to you, which actually tells the world that this is you. This is called data. If you append that data to the message that is being sent, it will be a proof that this is the sender. This is the authorized sender and this is the one who claims to be sending the message. And there are other ways also of digital signature. One is called as cryptographic transformation. You can do cryptographic transformation of a data unit that allows the recipient of the data unit to prove the source and the integrity of the data unit. Now, digital signature also protects against forgery. It will avoid forgery. It will avoid other people to copy your data and make it yours. That is called as digital signature. Moving ahead, the third security mechanism is access control. Access control. Now, what do you mean by access? Access is to access different data. Now, if you allow everybody to access everything, this is not security. This is not good to security. What you can do is you can restrict the accesses. You can restrict people from using the data. You can allow some people who are valid, who have work in that data, who have something to do in the data, only those can access the data. So by controlling the access to some things, to data, to sensitive information, also provides a security mechanism, also provides a way for security mechanism. That is called as access control. So there are a variety of mechanisms that enforce access right to resources. Huge amount of mechanisms are available that ensure that this person will have this access, this data, how much access, as to what access, what password, what user ID will be used by the sender to access the data. That is called as access control. Talking about the fourth specific security mechanism. This is called as data integrity. We've already discussed about integrity. The word integrity has already been discussed earlier. I told you the assurance that the data received is exactly as sent by an authorized entity is called as integrity. In simple words, integrity can be ensured by ensuring that the message that was sent by the sender is exactly received by the receiver. There's no change, there's no modification in the message. If the exact message is also received by the receiver, then this is called as ensuring integrity. Now, data integrity. To ensure integrity, you need to have certain security mechanisms. And there are a variety of mechanisms used for ensuring integrity of a data unit. Again, I should mention, since these are specific security mechanisms, so for different layers, for different specific layers, there will be different security mechanisms. Moving ahead to the fifth specific security mechanism. The fifth specific security mechanism is called as traffic padding. Now, what do you mean by traffic padding? Traffic padding basically means inserting bits into gaps of data streams. Now, all of us know that when we send a message is not sent completely at one go. It is sent by making packets. Different data packets are made of that individual message and then sent. So, traffic padding is basically padding or inserting bits between the two data streams just to frustrate the traffic analyzers. All we have to do is, all we are doing by traffic padding is we are trying to frustrate, we are trying to confuse people who are sitting in the network to analyze the traffic. That is called as traffic padding, and that is another specific security mechanism. There are different mechanisms for traffic padding which are very specific to different OSI or different protocol layers. Moving ahead to the sixth specific security mechanism, which is routing protocol. Routing control protocol. Now, what do you mean by routing control? Routing control means to control the route through which the packets are traveling. Now, all of us know that in the network, there are different routes. From the sender to the receiver, there are many ways. There are many ways through networks to travel. A packet from the sender to the receiver can travel from many ways, many paths. Now, routing control is a methodology or is a mechanism that helps the sender, or that helps the sender side applications to choose the best path out of the many paths that are available for sending a message or a data stream. So basically, routing control enables selection of particular physical secure routes for certain data to travel from the sender to the receiver. Moving to the seventh specific security mechanism, which is notarization. Notarization. Now, what do you mean by notarization? When we talk about notarization, the third party comes into picture. Third party, or the trusted third party, is the one who decides certain standards or certain rules through which, or by following which, the sender and the receiver will exchange message or will communicate amongst themselves. So by both sender and receiver will agree to certain standards that the third party will decide. This is another security mechanism, specific security mechanism used for ensuring security in different organizations. Moving ahead to pervasive security mechanisms. Now, what do you mean by pervasive security mechanisms? Pervasive security mechanisms, as I mentioned earlier, are the ones that are not particular to any OSI security services or protocol layers. In fact, they are general. They are available to all. The first pervasive security mechanism is trusted functionality. And the second one is security recovery. Talking about this trusted functionality. What do you mean by trusted functionality? Trusted functionality is the functionality that which is perceived to be correct with respect to certain set of criteria. Now, trusted functionality is like somebody has posed certain standards. Somebody has set certain standards. And trusted functionality is the one that ensures that those set of standards are actually being met. I hope you can understand. Again, I will repeat. Trusted functionality is the one that is perceived to be correct according to certain standards. Certain set of standards are already given by different organizations or different deciding standard organizations. And when we do certain thing, when we do certain communication between the receiver and the sender, the set of criteria that has to be met should be correct according to the criteria that has been set by the organizations, or that has been set by the standards. That is called as trusted functionality. Moving ahead as to what is security recovery. Security recovery is, by the name itself you can understand, this mechanism deals with recovery. Majorly deals with recovery. Recovery of what? Recovery of certain actions. There are different actions that can be done, different actions that will be lost by a communication due to power failure, due to network failure, and we need to recover them. So pervasive security mechanism provides you security recovery mechanism to recover actions that have been done. Along with the recovery action, security recovery mechanism also deals with event handling and management functions. That is called as security recovery mechanism. So basically we have completed the topic security mechanisms. Mechanism means to detect, to recover, to prevent. Security mechanisms can be divided into specific security mechanism and pervasive security mechanisms. Specific security mechanism can be further classified into encipherment, digital signature, access control, data integrity, traffic padding, routing control, notarization. Talking about pervasive security mechanisms, they can be further categorized as trusted functionality and security recovery. Moving ahead, we will be discussing certain terminologies. After understanding these terminologies, only then we can jump on to encryption. So let's understand these terms. The first term is cryptography. Since the name of the subject itself is network security and cryptography, and we've already talked about security, we need to talk about what is cryptography. Cryptography. Now, the word cryptography is often associated with scrambling the plain text. Now, whatever plain text, what is plain text? Since the word plain text is being used, and I'm saying that cryptography is scrambling the plain text, what is plain text? Plain text is the plain message, is the message that you can understand, that everybody can understand. That is called as plain text. Now, cryptography is the technique wherein the plain text is scrambled. This plain text is scrambled to form ciphertext. Now, plain text is the text that everybody can understand, and ciphertext is the text that is hidden, or that is scrambled form of plain text. So basically, cryptography is associated with scrambling plain text into ciphertext, and then back again, that is then converting ciphertext into plain text again. So cryptography is not just converting plain text into ciphertext, it is also converting back ciphertext to plain text. If you have to study the standard definition of cryptography. Now, the standard definition of cryptography says it is a science. It is a science, or it is a study of the techniques of secret writing. I hope you can understand. See, cryptography is the technique, or you can say it is the art or science of converting plain text into ciphertext. I hope you've understood the meaning of cryptography. Now, the second term that we cannot understand is cryptanalysis. Now, this term is very important. Often, many of us get confused between cryptography and cryptanalysis. Now, cryptography and cryptanalysis. We've already understood the meaning of cryptography. Talking about cryptanalysis. Cryptanalysis is the study of analyzing information system in order to study the hidden aspects of the system. Once again, I would like to repeat, what is cryptanalysis? Cryptanalysis is the study of analyzing the information If you remember, there is a lot, analysis can do a lot. We've already studied traffic analysis, and we know that even if you are not seeing the message, even if the message is in ciphertext form, even then a lot can be done. Even then a lot analysis can be done by just observing the traffic. And similarly, cryptanalysis is also the study of analyzing information system, study of finding out the hidden aspects, study of breaching the cryptography techniques. Do you understand? What do you mean by breaching? By breaching, you mean you are trying to break the ciphertext. Cryptanalysis is breaching the ciphertext into plain text. Cryptanalysis is actually an attack. If I say crypt analysis, I am doing crypt analysis, I mean I'm doing an attack. I'm doing an attack to what? I'm doing an attack to ciphertext, maybe to find out what is the plain text. I have the ciphertext, I have the wrapped message, and I do not know what is the plain message, and I am crypt analyzing. Then I am doing what? I am actually trying to find out the hidden aspects of the system that will let me reach the plain text. That is called as crypt analysis. So crypt analysis is breaching cryptographic security. So there's a huge difference between the cryptography and crypt analysis. I hope you will remember this. Moving ahead, as to the third term, which is encryption, the most important term that we're going to study further also. Encryption. We've already studied different security mechanisms, different security attacks. And we also saw that there's a release of message content. If you remember, passive attack, the types of passive attacks also has an attack called as release of message attack. Now this release of message attack, I told you there's a solution. If you remember, I told you there's a solution for release of message content, and the solution is encryption, and the solution is encryption. Encryption means you convert the plain text into ciphertext. Encryption means you're converting the plain text into ciphertext. Okay. To understand more what is encryption, we need to study certain terms which are associated with encryption. The first term is the plain text. I've already discussed what is plain text. Plain text is something that I can understand, that you can understand, that is the original data or the original message. Moving ahead, as to second word. Second is encryption algo. What do you mean by encryption algo? Encryption algo is a mathematical algo, or is a way of performing various techniques on plain text to convert plain text into these scrambled words, which is ciphertext. So encryption algorithm is a method, is a written set of method that converts your plain text. I hope you've understood this. Moving ahead, as to secret key. Now what do you mean by secret key? Secret key is also an input. Secret key, this secret key is an input to encryption algorithm. Every encryption algorithm needs a secret key, needs a key. So key is basically an input to the encryption algorithm. And also one more thing, this value of key is independent of plain text. It does not depend on plain text. The choice of secret key, whatever you choose to be a key, is not going to depend from anywhere on plain text. And this is going to be the input to encryption algorithm. I'll be discussing more on keys. I'll be discussing what is key in detail when I am discussing the terminologies, what is encryption and the techniques of encryption. There I will again repeat what is secret key. For now, you must know secret key is an input to the encryption algorithm and it is completely independent of plain text. Second word is ciphertext. What do you mean by ciphertext? We've already seen ciphertext is a text that nobody can understand. Ciphertext is a text that nobody can understand. It is a hidden form of plain text. That is called as ciphertext. Moving ahead as to decryption algorithm. Now this decryption algorithm is a reverse of encryption. Decryption is completely as reverse of encryption, which means decryption converts ciphertext into plain text. If encryption converts plain text into ciphertext, then decryption converts ciphertext into plain text. And we've already studied the conversion of plain text into ciphertext and conversion of ciphertext into plain text is completely called as cryptography. Okay. We'll be moving ahead. Going deeper into encryption. We've already discussed what encryption is and various words associated with encryption. We'll be further classifying encryption. Now, this encryption word can be classified into two. One is symmetric encryption and the second one is asymmetric encryption. Symmetric encryption and asymmetric encryptions are huge, are different, are widely different. Talking about symmetric encryption, before going into asymmetric, I will first discuss symmetric encryption and then we'll be going into asymmetric technologies. Now, what is symmetric encryption? Symmetric encryption is a form of crypto system in which the encryption or decryption are performed using the same key. I repeat, whatever you're doing in encryption and whatever you're doing in decryption, both encryption and decryption will have the same input. If you remember, I told you that the encryption algorithm and the decryption algorithm, both will be inputting as secret key. They need a key. Encryption algorithm also need a input as key, and decryption algorithm also need a input as a key. Now, if this key is same for encryption and decryption, then this is called as symmetric encryption. Symmetric encryption is an encryption wherein the encryption algorithm and the decryption algorithm both use the same key. They're not different. Okay. So I hope you can understand what is symmetric encryption. One more thing, symmetric encryption is also called as conventional encryption. Very important. Often in exams, you're asked as what is conventional encryption. So when they say conventional encryption, it is same as symmetric encryption. Okay. I would also like to tell you some more things about symmetric encryption. Symmetric encryption transforms the plain text into ciphertext using secret key, and an encryption algorithm is needed. Using the same key, a decryption algorithm is also used, and then the ciphertext is converted into plain text. So entire procedure of symmetric encryption is converting. If you see this diagram, you can you can understand the entire procedure of symmetric encryption. The entire procedure of symmetric encryption holds the sender will first form plain text. Okay, sender will first form a plain text. Now, he would definitely not want this plain text to travel as it is on the network. He would want that this plain text should now be converted into a form that nobody sees. So what will be done? Now encryption will come into picture. Encryption will first convert this plain text into ciphertext. कैसे करेगा? By using encryption algorithm. Now the plain text will be serving as an input to encryption algorithm. Along with the plain text, there will also be a secret key that will be serving as input to the encryption algorithm. Now what will happen? Now this encryption algorithm will convert the plain text into ciphertext. And this ciphertext message will be traveling throughout the entire network as it is. While it reaches the receiver end, what will happen at the receiver end? At the receiver end will deploy a decryption algorithm, which will be same as the which will be reverse as the encryption algorithm, and it will be taking the same input as the secret key. And this will do what? This will convert the ciphertext into plain text. That is called that is the functionality of decryption algorithm. And if we compile the entire methodology, this is known as the model of conventional encryption. Now there are further breaking of symmetric encryption or the conventional encryption into types of symmetric encryption. Symmetric encryption can be further divided in two types. The first one is the substitution technique. And the second one is the transposition technique. Now, there's a difference between substitution and transposition. Before understanding substitution and transposition, you must be very clear with what is symmetric. Always keep in mind that symmetric means encryption and decryption. Both will be using the same shared secret key. Now coming on to substitution technology. Substitution technique. There are various types of substitution techniques. Before understanding the types of substitution techniques, we'll be first understanding what do you mean by substitution. Now, in layman language, substitution means to substitute some value from the other value. That is called substitution. And in terms of encryption, a substitution technique is the one in which the letters of plain text, are replaced by the other letters or numbers. For example, if I say, hello, I am Akanksha. Now what would happen? Now the substitution technique will convert the plain text or will substitute the plain text from the other words. For example, I substitute H. How many H are present in this plain text? 1, 2. Okay, only 2 H is there in my plain text, and I decide to substitute how many ever H are there in my plain text by X. If this is the decision that has already been taken, what will happen? Zello, I am X. So what have I done? I have substituted H by X. I have substituted H by X. Understood? Understood the meaning of substitution? Okay. Also understand the meaning of transposition. Before going into what is substitution, types of substitution, also understand what do you mean by transposition. Now, transposition is a method of encryption by which the positions that are held by the plain text are shifted. For example, hello, and I decide to shuffle the ordering of these letters. Again, understand what I'm saying is I'm shuffling the order of these letters. I decide that the entire ordering will be the reverse ordering. Now what will happen is O will come first, L, E and H. What have I done? I've completely reversed the ordering. So transposition means reordering. You basically reorder, and substitution means you're substituting the plain text, the letters of the plain text by the other letters. That is called as substitution technique. Now, substitution techniques can be of various types. I'll be discussing the first type today, and rest of the types will be discussed in the future videos. Okay, the first type is Caesar cipher. This is the first type of substitution technique. Now, Caesar cipher. Why is it named Caesar cipher? If you remember, all of us have studied Julius Caesar. Somewhere around class 12th or class 10th, all of us, or if you haven't studied, you would have heard about Julius Caesar. Julius Caesar was an emperor. He was a king. Now, in his era, the messages were sent in a way. How it was sent? In his era, the message was converted into a secret form, and then it was given to the person who took the message to the other party. And this secret form was a methodology. And Caesar cipher technique has evolved its technique from the technology that was used in that era. So let's discuss what is Caesar cipher. Caesar cipher is the earliest known use of substitution cipher. It was the first substitution cipher that was used, and it was very simple. The Caesar cipher involves replacing each letter of the alphabet, with the letter standing just the 3 places further down the alphabets. I'll explain what I've said. Understand. For suppose I have a plain text, and my plain text is meet me after party. Now, Caesar cipher does what? Caesar cipher uses key as 3. There are other variations of Caesar cipher. Initial variation was using key as 3. Now, by using key as 3, what do you mean by key as 3? Now, 3 means, if I have to say the alphabets, if you know the English alphabets, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and similarly all the alphabets. A number is assigned to each of these alphabets. A is assigned as 0, B is assigned as 1, C is assigned as 2, D is assigned as 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and so on, and so on. So key 3, what do you mean by key 3? When I say key 3, I mean there should be, we must first find the place of M. First find what is the order of M, numerical order of M, which is 12. And when I say key 3, I need to do what? I need to do 12 plus 3. Now 12 plus 3 will give me what? 12 plus 3 will give me P. If I do plus 3, 12 plus 3 will give me 15. And 15 is the value of P. Understood? No. Still not understood. Okay. I will again repeat. We'll be first finding the place order of all the alphabets according to the number value that we have decided. A will be given the number 0, B will be given the number 1, C will be given the number 3, D will be given the number, C will be given 2, D will be given 3, E will be given 4, and so on. So first find out the value of all the alphabets in the plain text. For example, I picked up M and found out the value as 12 from the values, and then I will be using key, and I will be adding this key value to the original value, and 12 plus 3 will give me 15, and 15 is the place value of 5. I hope you can understand this. Similarly, if you want to convert meet me after party into ciphertext, the entire conversion will have P, H, H, W, P, H, D, I, W, H, U, and party is V, D, U, W, B. I will also, I'll give you another example, another demo. Again, the second word E. Second word is E. Okay. Find out the place value of this. 4. 4 plus 3. Again, the key value is 3. 4 plus 3 will give me what? 4 plus 3 will be giving me the value 7. And the 7 place value is of H. Therefore, E is substituted as H. Again, there's E. So there is again H, because we know that the value of E will be always 4, and 4 plus 3 will always give me the value 7, and the 7 is the value of H. Okay. And similarly, we have converted the entire plain text into the ciphertext. So this is the entire explanation of Caesar cipher. There's another way of converting the Caesar cipher. This is very difficult. Every time you do a plus and then convert something will be a difficult methodology. So there's an expression. There's an expression that helps you in converting the plain text into ciphertext and ciphertext into plain text. See that expression? The expression is C is equal to E 3 comma P, which is equal to P plus 3 mod 26. Why are we doing mod 26? We're doing mod 26 because we know that there are, how many alphabets are there? 0 to 25. How many alphabets are there? If you start the counting from 0 to 25 alphabets are there. So mod 26 means cycle. if I take these smaller values, if I say mod 2, it means 0, 1. If I say mod 3, it means 0, 1, 2. If I say mod 6, it means 0, 1, 2, 3, 4, 5. If I may, and here if I say mod 26, it means 0 to 25. Okay. We'll be discussing the modular arithmetic also in module 2. Do not go deep into what do you mean by mod or modular arithmetic. We'll be discussing that in brief in unit 2 or module 2. Here, what is C? C is the ciphertext. E is the encryption algo. And encryption algo, you always know that encryption algo takes key as the input and plain text as the input. So encryption algo will be taking key as 3 as input and plain text. And the expression is P plus 3. Whatever is the value of P, we'll be adding plus 3 to it and doing mod 26. Why will be doing mod 26? Why we'll be doing mod 26? We'll be doing mod 26 because if you have letter Y, for example, you have a letter here as Y. And if you perform plus 3 for it, X, Y, Z, Z, after Z there are no letters, right? And I still need a value, and that too in alphabets. What will be there? There will be a circle. After Z, the value of A should repeat. Therefore, we are performing mod 26. Okay. Thank you, class. We'll be discussing this again in the next lecture.